Welcome, everybody, to your free GMAT Prep Hour. It is July 30th, 2024. My name is Reed Arnold. I will be your host through the wonderful world of the GMAT tonight. If you're looking for other free prep options, please know that we have them out there. You can try the first class of our 9-week course for free. I always say that's something you might as well do, even if you have no intention of signing up for the course. We talk about some major stuff in class one. We talk about data sufficiency strategies. We talk about just broad test taking and study strategies pertinent to the GMAT. We'll talk about critical reasoning, some big high level stuff about that, verbal question types. So we get a lot out of the way in class one, and it is totally free for you to access. You can also do a similar thing with our interactive on-demand course. That is our video self-paced study course, but you can get the first session of that free of charge. Again, if you have no intention of signing up, you might as well do it. It's free content for you. We also run Foundations of GMAT Math workshops twice a month, usually, sometimes more. There are 2 5-hour workshops for you to take. One is the Foundations of Math Computations that is focused on kind of fast calculations, fast and accurate calculations for the math section, since you do not have a calculator for that. We then have a Foundations of Math Variables session, and that is focused on more algebra, translating word problems, solving for one variable or multiple variables, plus some kind of GMAT tricks that they can throw into the mix. You do not have to take those in any order. They both stand alone, but you will find that they communicate with each other. So hope to see you at one of those soon. We also have these, the free GMAT prep hours. These are all on YouTube in a very rich library. We have a full syllabus worth of material, if not more, available to you for those studying on a budget. You can honestly get everything you need, I think, from these free GMAT prep hours. So take a look at those. Today's lesson, we are going to be learning about conditional logic on the GMAT. And this is a lesson I'm very excited for. Conditional logic is something that for years and years and years, I wondered, should I talk about this? Is this something that I need to teach my students? If you have any experience with the LSAT, you know a lot about conditional logic. But for those of us studying for the GMAT, you might not have really dug into this topic very much. And I really wrestled with that for years because it was never explicitly tested. But I recognized, having taken a college course in conditional logic and done a lot of practice with conditional logic, I recognized that in like the guts of the test, underneath some of the topics that were, surface level being tested, I recognized that conditional logic was in play. And I always wonder, like, do I need to have just a session on this? Do I need to teach my students about if-then statements and modus ponens and modus ponens and modus tollens and affirming the consequent, denying the antecedent, all terms we're going to talk about today? Or do I not need to worry about it because it is buried underneath? And I think maybe if you don't need to get that deep, right? But I always wonder, there's always that like thing nagging at me like, oh, maybe my students would be better if they went through some symbolic logic training. Well, turns out when the GMAT changed to the GMAT focus this year, that the content of the test changed, and now conditional logic is explicitly tested. It is on the page right there in front of you to see. So it's not the most common topic, but it does show up. And I decided that that's a great chance for us to finally have a lesson on conditional logic, knowing that it will help you on those questions where it is explicitly tested. But I do think getting good at it might also help you on other questions and just with general reasoning skills. So I do think that this lesson will apply to more than just the questions that deal with conditional logic. I think getting good at it will help you with kind of just logical inference making. Now, this is kind of it's going to be kind of a crash course today. We're going to scratch the surface and get some big stuff out there for sure. But there could be other lessons down the road dealing with conditional logic on this test. But what I'm going to do is I'm actually just going to first throw you all to the wolves here. I'm going to pull up here a bunch of statements that look very similar. They deal with similar things and similar ideas. And what I'm going to tell you is that some of these statements are identical, meaning they tell you the same information. Okay. And it's your job to figure out which of these statements match. Okay. Now, It could be that 3 of them match. It could be that 10 of them match. But I will say this, that every statement has at least one other statement on the page that it tells the exact same logical condition for. And so I'm going to give you here, this will take a little bit of time because it's going to get, you're going to have to think pretty hard about some seemingly simple stuff to really see this. I'm going to give you a good 8 minutes to work on this. And I want you to really think about each sentence and see which other sentences on the page it matches with. 8 minutes might not be enough time. In fact, if you're watching the recording here, you might want to pause and spend more time than 8 minutes. But I'm going to give us here 8 minutes to do this exercise. And I will jump back on and talk about which of these are actually identical statements. All right, so that was about 8 minutes. Again, if you're at home watching a recording, feel free to pause and keep working. But I'm curious, those of you that are in the room, did we notice anything about the pattern for which of these sentences were equivalent? And I also would say I should add probably one, I think I should add a word to one of these. I think I should say on Mondays, I always go to the grocery store on this one here to be really careful. I'll explain why in a little bit, but shouldn't change too much. Anyone notice a pattern about these, about which sentences were the same? Not seeing any answers here, so I'm going to go ahead and spoil it. It was actually split right down the middle. Every sentence on the left side of the screen is the same sentence, and every sentence on the right side of the screen is the same sentence. These all mean the same thing as each other. If I say I must go to the store since it's Monday, that's the same thing as saying every Monday I go to the store, or only if I go to the store is it Monday. Those all mean the same thing. And on the other side, every time I go to the grocery store, it's on Monday, means the same thing as if I go to the grocery store, it's Monday. Okay. Um, so I want you to take a second, if that wasn't clear to you, I want you to take a minute to look over these and see if you can identify, see if you can understand why these mean the same thing down the columns, and also why they don't mean the same thing as each other. Why do the ones on the left not equal the ones on the right, but why are they each the same in the columns they're in? Take a minute just to reflect on that, just to see if you can, if it makes sense. Look at the ones you missed. Look at the ones you didn't realize were the same. See if you can understand why they tell you the exact same information. Here's a hint to understand this. Try to identify which words in these sentences build the logic of the statement being made. Which ones give you a strong idea for what circumstance, we'll use that word here a lot in a second, what circumstance triggers which circumstance. See if you can just find the logical words here. So some of the words you might look out for would be words like if or then, the words only if, every, each, all, or any, always, never, whenever, when, not builds logic often, must can build logic because it implies what must be true, what is necessarily true. So go ahead and take another stab at these with these words in mind And here, let's actually just write them down over here. So you can look, so you can kind of see them. Oops, don't do that. Read. Okay, I'm going to write down these words. You keep an eye out for them. If and then, only if, every, each, all or any, when or whenever, never or always, not, must. Look for these words and understand the logical implication that they are building in the sentence. Dua, that's a good question. We will address it shortly. All right. If you want to keep working, if you're watching the recording, please hit pause and do so. Please feel free. But for the sake of the time here for the live crowd, I'm going to keep moving. And we're going to talk about how these logical ideas get constructed with these words. So let's first give a translation that I find very useful when I'm thinking about conditional logic and conditional logical situations. If, the word if, means in circumstances that, right? So if it is raining, the street is wet. That means that in the circumstance that it is raining, the street is wet, or the street will be wet. And this is what conditional logic is really about. It's about identifying what circumstances, I don't know if my camera's cutting in or not, I apologize if it's glitchy, but what circumstances mean what other circumstances. And you want to start trying to find that, right? Okay, oh, this sentence tells me that in this circumstance, this other circumstance must be true. So let's take a look at these left, all the statements on the left here, and let's think about the circumstances that it is constructing. And let's start with the kind of the purest version of a conditional statement. I didn't put it first, but this is the purest version of the statement here. What is this in terms of circumstance, right? What this means is in the circumstance that it's Monday, or in circumstances that the day is Monday, I go to the grocery store. And that tells, and look at all the other situations and try to see how they all give us that same situation. They all tell you that in the circumstance that it's Monday, I go to the grocery store. They do it in different ways. Sometimes they don't even mention Monday, right? Here they mention Tuesday through Sunday are the only days I don't go to the grocery store. Well, if Tuesday through Sunday are the only day, it's kind of weird to use only for 6 of the 7 days, but such is logic, you can do such silly things. Tuesday through Sundays are the only days I do not go. There's a not, another logical word. If these are the only days I don't go to the grocery store, then if it's Monday, I go to the grocery store. Because if I don't go to the grocery store on Monday, then Monday would be one of the days I don't go to the grocery store. But I've limited those days only to Tuesday through Sunday. All of these scenarios, all of these sentences tell me, and it's helpful to think about the Venn diagram of logic, right? They tell me that, hey, if these are all the Mondays, if orange is Mondays, let's actually be really clever with this. I hadn't even thought of doing this, but I now see that it's going to be kind of maybe a helpful exercise. On Mondays, I go to the grocery store. The circumstance is also that I go to the grocery store. Oh, I also mixed this up. Excuse me. The grocery store circle needs to be bigger. All right. If I'm in the Monday circumstance, I know I am in the grocery store circumstance. It must be true. If I'm in the orange circle, I must be in the green circle. Every instance, every Monday I experience, every circumstance that it's Monday, I go to the grocery store. Now, do ask a question here, and I think it's an important one, right? Does this mean that I can't go to the grocery store on Tuesday? No, actually. All of these sentences they perfectly allow going to the grocery store on other days of the week. And it's important to recognize that these do not mean if it's not Monday, I don't go to the grocery store. This is actually a logical fallacy called denying the antecedent, I believe. We'll talk about this more soon. But if it's Monday, I go to the grocery store does not mean I can't go to the grocery store on the other days of the week. It just means that every Monday, in the circumstance of Monday, I'm at the grocery store. Okay. And so we can identify, take a second and mentally highlight in the answers or in these sentences where the green and the orange overlap is and how the logical keywords tell you that this Venn diagram overlap is the logical overlap of this problem. Okay. So for instance, I'll do the first one here. So every Monday I go to the grocery store is the green. This is the orange. And let's actually use maybe a different word for the logical subset, right? In the circumstances that every Monday, in the circumstances of Monday, if it's Monday, in the circumstances of Monday, on Mondays, always. I added that word because I do think that word helps this be a little more specific, right? On Mondays, I always go to the grocery store. So there's never I'm never in this orange circle here and not in the green. I can be in the green, but not in the orange. But if I'm in the orange, I'm in the green. So take a second here and just look at the other ones and highlight mentally what logical words tell you that this is the Venn diagram of logic for these sentences on the left. I do want to take a second also to specify this one here, this second one, because it kind of seems strange. Like, how can these two be the same? This one says if it's Monday, I go to the grocery store. This says it's Monday only if I go to the grocery store. The if seems to be pointing to a different situation, right? Here, the if is attached to going to the grocery store, and Monday seems to be the, other part. And then down here, the if is attached to being Monday. But let's think about what this sentence means if we change it to mean in the circumstance that. This means it's Monday only in the circumstances that I go to the grocery store. That doesn't mean every circumstance of going to the grocery store is it Monday. Okay. That's it. The difference between only and every is important here. But this means I can't have a day where I don't go to the grocery store be Monday. This tells me, and a quick way to remember this, by the way, and this is what one of my LSAT teachers taught me, and I thought it was great. Only if means then. It's just a quick mnemonic to tuck in your pocket, because the difference between if and only if, I can't stress enough. It took me like 3 weeks to understand. So I'm doing this in about 4 minutes. This is a real crash course. Because it does feel like, shouldn't those be opposites? It's Monday only if I go to the grocery store. If it's Monday, I go to the grocery store. It seems like a different if. The hypothetical if seems to attach to a different part of the sentence. But think about it as in the circumstances that. In the circumstances that it's Monday, I go to the grocery store. It's Monday only in the circumstances that I'm going to the grocery store. If it's not a day I go to the grocery store, it can't be Monday. Because I go to the grocery store on Mondays. Okay. And so I have a question from the chat here. What is the difference between, I'm going to cover up the statements here. Like, what is the difference between I do not go to the grocery store Tuesday through Sunday, and Tuesday through Sunday are the only days I do not go to the grocery store? Okay, so first off, I'm going to spoil it and show you what the if-then statements of these are. This means if it is Tuesday through Sunday, I don't go to the grocery store. Okay. This means the only days I do not go to the grocery store. Tuesday through Sunday are the only days I do not go to the grocery store. If I don't go to the grocery store, then it is Tuesday through Sunday. Let me make sure I believe that. I said that a little bit hasty. Let me see if I believe that about myself. Tuesday through Sunday are the only days. Yes. Yeah, I'm pretty sure that's true, because let's think about the situation, right? Tuesdays through the only circumstances I don't go to the grocery store are Tuesdays through Sunday. That's the only times I'm not at the grocery store. It's Tuesday through Sunday. That means if it's Monday, I'm at the grocery store, right? That means this equals, if it is Monday, I go to the grocery store. But let's think about this one on the left. This one on the left does not tell me I go to the grocery store on Mondays. I could or I could not, right? Do I go on Mondays or not? Maybe I don't. it's possible it's possible I don't go Tuesday through Sunday, and also I don't go Mondays. Or maybe I don't go Tuesdays through Sundays, and I go some Mondays, or and I don't go Mondays. Or I don't go Tuesdays through Sundays, and I go every Monday. All of it is possible. But what I know for sure is that if it's not Monday, right, this does mean equals, if it's not Monday, I don't go to the store. Right? If Tuesdays through Sundays, I don't go to the grocery store, then if it's not Monday, I'm not at the store. And this statement on the right, no, careful. This statement on the right does not mean I don't go Tuesdays through Sundays. It says Tuesdays through Sundays are the only days I don't, I'm sorry. It doesn't mean I can never go Tuesdays through Sundays on the right. If Tuesdays through Sundays are the only days I do not go, that doesn't mean I can't go sometimes. But they're the only days I'm allowed to not go. On Mondays, I'm not allowed to skip. I go to the store because Tuesdays through Sundays are the only days I don't go. They're the only days I'm allowed to skip. Mondays, I got to go. If it's Monday, I go to the store. That doesn't mean I don't go Tuesdays through Sundays. It means I might not. They're the only days I can skip. If I do skip, you know it's not Monday, but that doesn't mean I can't go also. This is tricky. This is a tricky subject. And again, I spent weeks learning this stuff. I'm trying to give you a crash overview in an hour. But one of the important distinctions is, that these are different sentences. These mean different things. And it is the exact difference between these two columns that we had before, right? Because this Venn diagram was if it's Mondays, if it is Mondays, I go to the store. I have to go to the store. That doesn't mean I might go to the store Tuesday also. Maybe not. I don't know. But if it's Monday, I got to be at the store. The one on the right, this column, draw the Venn diagram for these sentences. My Monday in orange again, and my grocery store in green. And I'm going to use the logical connector to be red. If I go to the grocery store, then it's Monday. Okay, so that means in the circumstances when I go to the grocery store, in every circumstance that I go to the grocery store, it's Monday. So now the Monday is the bigger circle. If I'm in that grocery store, it's got to be Monday. That doesn't mean every Monday I go. But if I do go, it's Monday. And if it's not Monday, I don't go. Every circumstance of going to the grocery store happens within the circumstances of Mondays. Take a second to understand how each of these sentences tells me that that's the relationship. Grocery store happens as a subset of Mondays, but not necessarily every Monday. There are some sentences, we're not going to deal with these too much today. There are some sentences that do mean every Monday I go and only on Mondays I go. The most common is if and only if, right? We combine the if and the only if. Remember, only if means then. So if I go to the store, then it's Monday, and only if it's Monday. These sentences tell you that it's a two-way street. If I'm at the store, it's Monday, and if it's Monday, I'm at the store. If it's Tuesday, I'm not at the store, and if I'm not at the store, it's not Monday. Okay. There is total overlap, but we're not going to worry too much about these tonight. We're going to focus mostly on, I forget what they're called, one-way conditionals, not a biconditional. Okay. So we've already kind of touched on this, but let's talk about some logical fallacies that happen with conditional logic, and the GMAT can put trap answers using these fallacies. The first is called affirming the consequence. If P, then Q, therefore P. So using the example we just had, if it's Monday, I go to the grocery store. I'm at the grocery store. Does it have to be Monday? No. If it's Monday, I go to the grocery store, but maybe I sometimes go Tuesdays also. So it doesn't have to be Monday just because I'm at the grocery store. This is called affirming the consequent. Denying the antecedent, if it's Monday, I go to the grocery store. It's not Monday, so I must not go to the grocery store. Similar idea. Both of these deny the possibility that, hold up, maybe you go on Tuesday also, or Wednesday, or Friday. I know if it's Monday, you go. I don't really know about other days. I know if you don't go, it's not Monday, right? But I don't know if you go on other days. So these are two logical fallacies to avoid with conditional logic. And then there are the two, and in particular, the one logical inference that you want to be very familiar with. The first one up here is going to be fairly straightforward, right? If it's Monday, I go to the grocery store. It's Monday. Or, it's not Tuesday through Sunday. Same idea, right? That means it's Monday. So I'm at the store. I'm going to the store, right? That's has to be true. If P then Q means P means Q, right? That's fairly straightforward. The second one is trickier. And we've already hinted at it a few times today, but it's one you definitely want to be aware of. It's one the GMAT uses a lot. They do this kind of thing with some frequency. If it's Monday, then I go to the grocery store. Means if I don't go to the grocery store, it's not Monday. That has to be true. Another way of saying that is if I don't go to the grocery store, it's Tuesday through Sunday. You can't have P without, I'm sorry, you can't have, you can't have P without Q. That's why if you really get into formal logic, Q is called necessary, the necessary condition. It must be true. It needs to be true when P is true. If P is true, Q can't be false. It's necessary. So if you don't have the necessary condition, if you don't have P, if you don't have Q, you don't have P. Because Q is necessary along with P, right? If I don't go to the grocery store, it's not Monday. Because if it's Monday, I go to the grocery store. So if I don't go to the grocery store, it can't be Monday, right? That's just a logical flip of each other. All right, that's a crash course on this. Can I answer any questions before we move on? Again, we're moving through this very fast, but I wanted to get a good overview out there. Okay. Some ambiguous language to be aware of, and this is why I changed earlier. I had a sentence very similar to this one, but I wanted to add always because it's just a little more precise. If P did not, yes, good, do it, yes. So quick question here. If P did not happen, we don't know if Q, right? So if P then Q, not P, that doesn't mean not Q, right? So again, if I go to the grocery store, if it's Monday, then I go to the grocery store. It's not Monday. Does that mean that I don't go to the grocery store? Must I not go? No, I can't. I'm allowed to. I'm allowed to go to the store on not Mondays. I'm just not allowed to skip on Mondays. So if it's not Monday, you don't know if I go to the store or not. Okay, so not having P does not mean you don't have Q. You may or you may not. Now there are the GMAT, especially in its reading problems and critical reasoning problems, they use language that's not as logically precise as what we saw before, right? They don't necessarily use the words like always, never, if, then, all, every, each, right? They'll say things like, because it's Monday, I go to the grocery store. And at first that kind of feels like the same. That kind of feels like, oh, well, then you must go every Monday. But the word because actually doesn't have pure logical power. Think about because I dropped the cup, it broke. That doesn't mean that if you drop a cup, it breaks. Sometimes you drop a cup and it breaks. But if you drop a cup, it isn't necessary that it breaks. It might break. Right? So we cannot say that this means because I dropped the cup, it broke. We can't say that this means dropping cups always breaks it, right? This does not equal that. You can't say that, right? If you drop a cup, it breaks. We can't say that with such certainty, but the GMAT does have ways of getting around that, right? What they might say, they'll use like squishy language. So they'll say things like dropping a cup could occur in the cup breaking, right? They'll use that kind of language, and that is fine. Okay, sure. That seems like a lot. If a cup broke because I dropped it, if that was the cause of the breaking, then sometimes dropping a cup causes it to break. I do know that. I can infer that. So notice it's just like they use that squishy language like could or might. That's how they make inferences on less precise logic or on less permanent or totalitarian logic. They'll use these squishy words like could, might, often, you know. So be on the lookout for that. But again, today we're dealing more with the pure logic that is now showing up on the test. But I do like to point out that because does not have logical power because there is a difference between causation and logical implication. And this is another thing that when I was studying logic myself, it really took me a long while to break, right? It's very hard to break this if I go to the store or if I go to the store, it's Monday. Like it's very hard to see how that's different than because it's Monday, I'll go to the store. These are not the same. It is not even the same as because I go to the store, it's Monday. Because is a weird word. Because has like physical causality, and it has knowledge causality, and it's very hard to know when it's used which way. And sometimes it's kind of used in both ways, right? Like because the cup broke because I dropped it, or someone must have dropped the cup because it broke. I'm guessing a physical cause, and I'm saying I know something because of a phenomenon, and those are not the same thing. So break the link between causation, like physical causation, and implication. What circumstances imply necessarily which other circumstances? Already 7:54. My goodness. Okay. Um, well, we're just going to power through. Okay. So I'm going to pull up here a little story about books in a library. And I want you to think about what we can infer based on this story. Go ahead and take, 5 minutes for this. Read the situation, understand the rules, and see what you can infer based on the different scenarios laid out. All right, so let's take a second here to annotate the different rules we're dealing with. We have the following constraints. Two books by the same author cannot be displayed. So that means, and you have a way to kind of label the conditional logic you find, right? And one way to say this is that if I have book one by a certain author, if that is on display, then, and like have the left side mean on display, that means that not book two by that author, right? I can't have a second book by that author on display. I'm told by the same author cannot be displayed in 2 consecutive months. So if an author was on display last month, then that author cannot be on display now. And one thing you can do, and one thing I like to do, anytime I write one rule, I write the modus tollens flip of that, right? And it's kind of silly with this first one, but if book one is by an author, I can't have book two. And if I do have book two by that author, then I can't have book one. It's kind of a repeat, right? Because these book one and book two are just arbitrary books. That one's kind of silly, but this one is different, right? If I had an author last month, they can't be on display now. So if they're on display now, then they can't be on display last month. That has to be true. And then I'm told all the books have to be the same genre, and this month is horror. And what that means is that if it's on display, if a book is on display, so I'm going to say, how do I want to say it? If it's on display, then it's horror. It doesn't mean, right? Not every horror book gets displayed, but if it's on display, it's horror. If it's not horror this month, it's not on display. Okay, these are the rules. And now we look at the specific situation and we see what we can infer. So one says The Haunted Hospital by Stephanie Queen. That was my play on Stephen King with a female name. The Haunted Hospital by Stephanie Queen was not on display this month. What can we infer? Now you have to be careful here. Right? The left sides are the things that trigger information, right? So if a book by an author is on display, another book is not on display. If the author was on display last month, they're not on display this month. And if they're on display this month, they weren't on display last month. If they're on display, they're horror. If they're not horror, they're not on display. So notice that not being on display never triggers anything. And so we can't infer anything about the haunted hospital. Nothing. We can infer not a thing. Because not being on display on its own isn't a trigger. It could just be, I mean, it sounds like a horror book, right? They just didn't choose it. I don't know that Stephanie was on display last month, and that's why they didn't choose it. It could be, but it doesn't have to be, right? There's no inference you can make by not being on display. The second one's a little bit trickier because it doesn't say it's not on display. It says it can't be chosen to be on display. And I also want to point out here, if they say the following constraints on GMAT, this means these are the only constraints. And so if Tweet Cute, which by the way, this is a real book by my friend Emma Lord, it's a charmingly sweet young adult rom-com. Check it out if you're into such things. Okay. So before we move to Tweet Cute by Emma Lord, I have someone is wondering, doesn't the first one mean that it can be displayed next month? No, because maybe a different book by Stephanie Queen is on display this month, and next month you can't display the same author twice in a row. So I don't know anything about the Haunted Hospital. I don't know if it can be displayed this month or not, because I don't know if another Stephanie Queen book is on display this month. Maybe there's a Stephanie Queen book on display, and that's why the Haunted Hospital can't be on display. Or maybe not. Maybe they just didn't choose the haunted hospital. I don't know anything except that it's not on display. It doesn't trigger any knowledge. And yeah, do it just because notice that these, nothing here triggers a book to definitely be displayed. We have rules about what can't be displayed, but there's nothing that shows that it might, right? Not every horror book, if it's horror, it's displayed. That's not a rule. We know that if it's displayed, it's horror, but not every horror book is going to be displayed. But since these are the only constraints, and if we're told tweet cute can't be chosen, we can make some loose inferences here. It means either Emma was displayed last month, a book by Emma was displayed last month, or another book by Emma is displayed this month, or Tweet Cute isn't a horror book. So we don't know anything definitive, but we do know it breaks one of the rules because we're not told that it was not chosen. We're told it cannot be chosen. And so there's kind of a hidden constraint here that if it can't be chosen, it breaks one of the rules. But we don't know which rule it broke. Okay. If the Headless Horseman and also His Horse Has No Head, a great book by George R. R. Martin, if that is on display, what can we infer? Now, this does trigger some things because being on display does trigger certain constraints. We know that no other George R. R. Martin book is on display. We know that George R. R. Martin was not on display last month. And we know that The Headless Horseman and also His Horse Has No Head is horror. We can infer those three things because the book is on display. That triggers inferences. Okay. This last one, if A Fistful of Spiders is a Mary Shelley novel, and Mary Shelley was not on display last month, and no other Mary Shelley novel is on display this month, what can we infer? Not much, except that A Fistful of Spiders could be on display. We don't know it has to be, but it doesn't break any rules. Which is actually a little bit more than we can infer in that first statement. Right? The first statement, we don't even know if the haunted hospital could be on display because it's possible that Stephanie Queen was displayed last month or is on display now. But this, we know that theoretically A Fistful of Spiders could exist, or could be on, it exists, but could be on display. It does not exist. It's a made-up book. You know what I mean. It could be on display because it doesn't break any of the rules. It doesn't break any of the necessary conditions for being on display. Right? If it is on display, then no other book is on display. Great, we know no other book is on display, so it doesn't break this condition. If it's on display this month, it wasn't on display last month. Great, we know that it wasn't on display last month, so that's possible. If it is on display, it must be horror. We're told it's a horror novel, so it checks that box. So it could be on display. It fits all the necessary conditions, but it does not have to be on display. Just because something meets all the necessary conditions does not mean that it has to be on display. It just means it could be. Right? We have all of the cues here, right? If P then Q, Q. We have every Q. We have that it was, she's not on display last month, no other book is on display, and it's a horror novel. So we have all the cues, but we can't infer that it's on display. We can't infer the P. All right. Just a game of like building triggers and noticing what triggers which implication and when a trigger isn't pulled. If a trigger's not pulled, you can't infer much about it, about the situation. All right, this is a longer game. This is in the world of logic chains. You'll see why I call them that here in a moment. This might take a little bit of time, but I want you to understand the constraints up top, and then in each additional scenario, like if Bruno goes, in the sub scenarios, I want you to say whether something must be true, must be false, or is unsure. It could be either way. We don't know. We don't have enough with this information. This is going to take a little bit of time. I want you to take, oh, I'd say 10 minutes for this, because this is going to take a little bit of time to get through. I'll come back and talk you through it in 10 minutes. All right, that is 10 minutes. If you're working at home, feel free to keep chugging along. Okay, but I'm gonna, for the sake of time here, I'm gonna go ahead and move forward through this. A lot of constraints, and this is called a chain because you might recognize as you build these constraints and as you work with these constraints that they start to compound on each other. They start to affect each other. So when I see that that's what's happening, when I see that they're listing a bunch of if-then statements, a bunch of conditional logic, I try to kind of set up a chain and figure out where they intersect. I don't just start immediately copying. I kind of try to find a trend, right? So one thing I'm noticing is that Willa shows up a lot. There's a few Willas here. So I want to figure out what the constraints are around Willa first, maybe. So first off, Muffin only goes if Willa goes. So I can say that if Muffin goes, then Willa goes. Only if means then. Muffin only goes in the circumstances that Willa goes. So if Muffin goes, then I'm in a circumstance that Willa goes. Now this is if Willa does not go. So I'm going to skip this one for a second. But Willa only goes if Rocco goes. So I can build that. And then it says when Rocco goes, Sally goes. So I have this nice clear chain saying if I have Muffin, then I have Willa and I have Rocco and I have Sally. I can just lay that out. Things are good on that chain. Okay. Then they tell me if Bruno goes, Muffin cannot go. So let's go back to some rules I've skipped. If Bruno goes, I can't have Muffin. Well, that's the same rule as if I have Muffin, I can't have Bruno. So I actually have another chain here. I can say if Muffin goes, I don't have Bruno. There's another inference I can make there. Great. And then I have if Willa does not go. So if I don't have Willa, I must have Pounce. That means if I don't have Pounce, I must have Willa. Right? If Willa doesn't go, Pounce must go. So if Pounce doesn't go, Willa has to go. Because if Willa doesn't go, Pounce goes. But I'm saying Pounce doesn't go, right? You get into a contradiction. So I either have Pounce or Willa going. They can't both leave. They can't both skip. And so I can actually put this way, say not Pounce. That triggers Willa going. And then Rocco goes, Sally goes, but Rocco does not go if Yeller goes. So only if Yeller goes. So if Rocco's out, Yeller must be in, which means if Yeller's out, Rocco must be in. Very similar with the Willa-Pounce relationship. So I can say if not Yeller, then Rocco. And so now I have a full chain, and here's the nice thing. I can then just reverse it, right? We can go the other way. We can say that, okay, if I don't have Sally, then I can't have Rocco, and I can't have Willa, and I can't have Muffin. Right, and I can also say, hey, if Bruno goes, I know I don't have Muffin, so I can put that here. I have the Pounce-Willa relationship, right? If I don't have Pounce, I have Willa. If I don't have Willa, I have Pounce. So I can say if I don't have Willa, I must have Pounce. Same thing with Rocco. If I don't have yellow, I have Rocco. If I don't have Rocco, I have yellow. Yeller, excuse me. And so now I have the other chain that can fire. These are identical. These are actually not different. It just helps to have them both laid out. It's going to be easier on your brain to make them both. And with practice, it becomes fairly automatic. You just reverse each trigger. But an important thing to note about this chain, about either chain, they only fire along the arrows. The inferences do not fire back. And this makes actually the work we're about to do fairly easy. right? So for instance, if Bruno goes, well, when does Bruno go in our chain? Here. That only fires one trigger. It tells us Muffin does not go. This must be true. All of the rest are uncertain because the only trigger that Bruno fires, that Bruno going firing, the only trigger that Bruno going fires is that Muffin doesn't go. So all the rest, we just have no idea. We can't say for sure. Just because Muffin's not going, we don't know if the triggers to the left of Muffin not going get fired. Okay. We're starting at the end of the chain. If you start at the beginning, you can flow through, but if you start at the end, there's not much you can do, not much you know. Okay. So if Willa does not go, okay, well, that goes just a little bit further down the chain here. That puts us here. So what do I know? Rocco goes. Meh, I don't know that. Bruno goes. I don't know that. Muffin goes. That must be false. Because if Willa does not go, Muffin does not go. That inference is clear. So I know that this is not true. Muffin does not go. If Pounce does not go, where is the Pounce not go chain? Here it is. That starts at the beginning. So we actually get a lot from that. But Yeller, we don't know. Okay. And Muffin, we don't know actually, because Muffin's to the left of that trigger. Sally does not go. Actually, no, Sally has to go because if Pounce doesn't go, Willa goes, Rocco goes. Sally must go. So this must be false to say that she does not go. Yeller does not go. That puts us here. What has to be true? Muffin goes? I don't know. That's to the left of Yeller not going. Pounce does not go. That's also to the left. I don't know. Bruno does not go. I have no idea about that either. A lot of uncertainties in this one, apparently. That's okay. I did a lot of uncertainty. I don't think I meant to do this much uncertainty, but that's fine. The exercise is more about building the chain than making the inferences, I suppose. If Sally goes, that puts us here. And notice that fires absolutely nothing. So we just don't know anything. Boom, boom, boom. Yeah, I definitely didn't mean to put that many question marks. Makes me wonder if I've made a mistake. Either when I first made it, if I thought that more inferences fired, or just now. But I don't think I did. I hope not. It's always embarrassing when you make a mistake on the recordings, but especially on a problem I made up. But it has been known to happen. Okay. So if Willa goes, just to fire some, or if Muffin goes, right? We know Bruno doesn't, we know Willa does, we know Rocco does, we know Sally does, but we wouldn't know about Pounce or Yeller. I couldn't say if they went or not. Okay. I'm going to presume that I did that right and that you have a sense of how logic change works. Again, this is a crash course overview. I don't expect you to master all this tonight, but I want you to be exposed to how this stuff works. And now finally, at long last, an hour and a half in, I promise we're almost done. We're just going to do 3 more problems. Okay. I'm going to give you some actual GMAT-like questions that will use conditional logic. Let's start with a data sufficiency question. Hopefully you've done some data sufficiency here. If not, take a second to brush up on this question type. But take 2 minutes and choose an answer for sufficiency on this logical chain problem. All right, that is 2 minutes. For the sake of time, I'm going to go ahead and work out the answer here. We have a list of conditional statements. And again, I haven't said this in a while, but try to start seeing these things as, okay, in this circumstance, this other circumstance must be true. So when it is not winter, the temperature is hot. So in the circumstances that it's not winter in these places, it is hot. And every time Jeanette goes camping, Margot goes with her. So if Jeanette, in the circumstances that Jeanette is camping, Margot is camping. But Margot only camps in the summer and does not go unless, that's a word I should have mentioned earlier. That's another logical trigger word, unless. Okay, Margot only camps in summer. So if Margot's camping, it's summer. Okay. And Margot does not go unless her friend Trisha is with her. And so let's think about what that means circumstantially. Margot does not camp unless Trisha is with her. So if Margot's camping, Trisha's camping. That's what that means. In circumstances where Margot's camping, Trisha is camping. Okay. And let's also think about this summer thing, right? If it's not hot, that means it's winter in these places. Also, let's note that if it's not winter, it's either summer, spring, right? This means summer or spring or autumn. It's hot. So if it's summer, it's hot. So if Jeanette's camping, Margot's camping, Trisha's camping, it's summer and it's hot. I know all that. Conversely, I can reverse this chain. If it's not hot, then it's winter. If it's winter, it's not summer. If it's not summer, Margot's not camping. And if Margot's not camping, Jeanette is not camping. And what about Trisha? Well, all I know is that if Trisha doesn't camp, Margot doesn't camp. So I can draw this arrow here. These are my conditional chains. And again, they're identical. They look different, but they really tell the same story. And I want to know, is Jay camping? And already off the bat, right? This is a yes, no question. Nothing really triggers a yes answer. There's nothing that tells me Jay has to be camping, but I do know some things that result in Jay not camping. In particular, if it's not hot. And so sure enough, statement one tells me it's not hot, which means Jeanette is not camping. So statement one is sufficient. It gives me a no answer to this question. And remember, no answers are sufficient to yes, no questions because you have an answer. The answer is no. Jeanette is not camping. Two tells me Trisha is camping. But again, what does that trigger? Nothing. You've done trigger left, right? Trisha camping doesn't mean Margot's camping. If Margot's camping, Trisha must be there, but sometimes Trisha might camp alone or with other friends. I don't know. It's not enough to know that Trisha's camping. This is not sufficient. The answer is A. It's just based on the logical chain. Okay. So just one example of building a chain and how you might see it in data efficiency. Let's take another problem here. This is more from the data insights section. I'm going to use this same passage for 2 questions. So I'll give you full time for this question. The second one I might abbreviate a little bit because you'll have done a lot of the upfront work. Go ahead and take, 2.5 minutes to answer this 2-part column question. All right, that's about 2.5 minutes. So let's talk this one out. We have a bunch of constraints here. Productions, and they're making a film. They have certain constraints. Now, there's a fun little secret hidden constraint to note here up front, that whoever directs the film must also be in the cast. So if you direct the film, you must act. If you don't act in the film, you can't direct. That's a subtle little constraint to note, but it is important that you see it. Okay. And here's what we know. We know that Jennifer and Angelina cannot both be in the movie. So if Jennifer's in the movie, Angelina's not. If Angela's in the movie, Jennifer's not. Jennifer will be in the cast only if Greta is directing. Okay. So if Jennifer is in the cast, it's only in the circumstances Greta's directing. So if Jennifer's in the cast, Greta is directing, which notice that means also Greta acts because the director must act in the film. Ben and Matt will only perform in the movie if they're both performing it and if one of them directs. So if Ben is in the movie, Matt is in the movie. And if Matt is in the movie, Ben is in the movie. And also, I'm just going to put like a direct above. One of them is going to direct. Okay. I guess to be very specific, and I maybe should have put this, I should say that there's only going to be one director of this movie, which technically there are some movies that don't only have one director, but I meant for this to be a one director kind of movie. Auteur theory. And so let's note something, right? If Ben is not directing and or Matt is not directing, then we don't have Ben or Matt. No Ben and no Matt. And so here's another important distinction. If Greta's directing, then Ben and Matt are not directing. So I don't have Ben and I don't have Matt. Because if Greta's directing, they're not. And if they're not acting in it, they won't be in it. Okay. So I can do a little reversal here. If Jen is directing, I'm sorry, if Jen is in it, Greta is direct. So if Greta doesn't direct, Jen is not in it. Jennifer's not in it. And I know if Greta doesn't act, Greta doesn't direct. That's true of any person here. And I know that if Ben and Matt, if either of them are in it, they're both in it. And if they're in it, one of them's directing. So Greta's not directing if Ben or Matt is in it. So if Ben or Matt are in it, Greta doesn't direct, Jennifer's not in it. Okay. So now I'm told here the circumstance that must be true in this situation, and in B, the circumstances that could be true. That means all the wrong answers are things that must be false. So Ben and Jennifer performing the film together. I know that can't happen. If Jennifer's in it, Ben is out, and if Ben is in it, Jennifer's out. So that chain is already in. Jennifer does not direct the film. Now, I didn't really talk about Jennifer directing the film. But if Jennifer does direct the film, she must act in it. And if she acts in it, Greta directs the film. But if Greta directs, Jennifer doesn't direct. And so this is the one that must be true. I can't have Jennifer direct the film because if she's in it, Greta directs. So this must be true in this situation. Okay. Can Greta direct with Matt? No, because again, Matt demands that he or Ben direct. Can Matt direct and Greta perform? That is actually possible. Because Greta's performing in it. She's not directing in it. And Greta acting doesn't trigger anything, doesn't constrain us at all. So sure, Matt or Ben can direct and act in it, and Greta perform along with them and just not direct. That is allowed. But Jennifer cannot direct with Angela in it, because if Jennifer directs, she's in it, and she and Angelina can't perform together. Ben performs in the film, but Matt does not. Again, they have to perform together. That cannot be true. Okay, so Jennifer does not direct must be true, and Matt directs with Greta in it could be true. The rest must be false. All right, last question. Same setup, so you don't have to do quite as much work. I see now that the live audience is gone. I lost them an hour 40 in. That's understandable. Sorry this went so long, but again, it's a lot to talk about, and I still feel like I've gone too fast. Okay, there's still so much more to practice here, but hopefully this gives you a kind of a flavor of it. Let's try this version here. Same setup, a little bit of a different question style. But go ahead and use the same logic chains to help you. Take a minute after this. And actually, I guess you know what, since the group isn't here, if you're doing this, if you're watching the recording here, you can just hit pause and time yourself. I'm gonna explain the problem now because I gotta go eat. I'm hungry. So this is a two-statement question type, where sometimes you'll see these on Data Insights where each one is individual, where you'll have just one question and then a second question. But they also like to do versions where the two blanks are in communication with each other, where you have to make one cohesive statement from the two blanks. That's what we have here. We have to use these rules to make one true statement, where in one of these events, which of the following must be false? That's what we're looking for. And notice it cannot be the case. We're looking for the one that must be false, not the one that must be true. I could do either. Okay. So if Greta does not direct the film, what does that mean? It means Jennifer can't be in it. So if Greta does not direct the film, I would look for Jennifer being in it, because remember, I'm trying to find the one that must be false. So if you say Greta directs and Jennifer is in it, that wouldn't work. But unfortunately, none of these say Jennifer is in it. So A doesn't trigger anything else. I don't see anything there. Angelina does not direct the film. I don't even know what that doesn't trigger much at all. If she does not direct, she might still act. I don't, Angelina not directing doesn't seem to have much pertinence to the situation. If Jennifer is in the film, well, I know that triggers some things. For instance, I know it triggers that Greta directs, and I know that means that Ben and Matt don't direct, which means they're not in it. And so, now I see the pair that, right? If Jennifer's in the film, Matt can't perform in the cast. This must be false. So the CA relationship forms a true statement. If Ben directs the film, and by the way, Greta performs in the cast might be a trap answer here. This is one that must be true. And Angelina is not cast. That must be true. And Jennifer does not direct. That also must be true. We're looking for the answer that must be false. Okay. If Ben directs the film, Matt must perform in the cast. That must be true. Angelina could or could not be cast with Ben directing. So this does not have to be false. It could be false, but it does not have to be false. Greta can perform or not. Jennifer does not direct. That has to be true. If Ben directs, Jennifer does not direct. But again, we're looking for one that must be false. So the answer is C and A. All right. I know that's a lot, and I know I went long. I apologize for the free GMAT prep hour and 45 minutes, but hey, you're watching our recording, so what do you care? Hopefully this was helpful. And again, it's a crash course. We barely scratched the surface tonight, but hopefully you got a sense of how logic works and how conditional logic works. And I think a big thing to remember, or maybe didn't emphasize it enough, is that you really want to think of this as circumstantial, right? This is true in the circumstances that this is true. Build those triggers. Understand which circumstance means another circumstance has to be the case. Read with that in mind, looking for your logical keywords, which I'm going to add an important one, unless. Okay, that showed up in one of our problems here. All right, remember, if you're looking for more free prep options, we have it. Check out our upcoming courses and our free Foundations of Math sessions. And again, try our first class for free. We hope to see you out there. Until then, best of luck in your studies, and I will see you next time.